Welcome to the Real Python Podcast. This is episode 14. Would you like to run your Python code in the cloud without having to become an infrastructure engineer? Do you want to have Python functions that run when triggered by specific events? This week on the show, we have Anthony Chu to discuss serverless computing and running Python functions in the cloud. Anthony is program manager for Microsoft's Azure Functions. We discuss the advantages of serverless computing over virtual machines, containers, and other infrastructure options for running your Python code in the cloud. Anthony also talks about the types of projects suited for this type of platform, including data science, machine learning, and creating APIs. All right, let's get started. My name is Christopher Bailey, your host. The Real Python Podcast is a weekly conversation about using Python in the real world, interviews with experts in the community, and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Anthony, I want to welcome you to the podcast.
Thanks. Nice to be here.
I know all the stuff with Microsoft, the Build conference just kind of ended. What were some of the things that you were involved in there?
Yeah, I was involved in a few talks. Thankfully, I wasn't the main presenter. So my main goal was just to be there to read out audience questions. One of the cool things that we did was we ran it for 48 hours straight. And every session, we ran them 3 times.
Oh my gosh.
In different time zones. So we were able to interact with different people around the world. I'm not sure if we published the number of people that attended, but it was huge. So it was really cool because typically we only get about 5,000 or 6,000 people out to the Build conference. It's our smaller developer conference, but being online, we just opened up the doors and a lot of people came. So that was really cool.
Yeah, nice.
And they got to see the inside of our house and stuff like that.
So cool. What is it that you do currently for Microsoft?
Yeah, so I'm a program manager at Microsoft on our serverless computing platform, Azure Functions.
Nice. And that's kind of partly why I wanted to have you on here, is to talk about serverless computing and how that could be useful for people looking to do, Python in that space now. So maybe we should start a little bit of background and talk about, what is serverless computing?
Yeah, let's do that. So serverless computing at its core, I guess there's 3 things that we look at. One, as the name sort of implies, you kind of don't think about the servers. Obviously, somewhere there is a data center, there is a server, but we try to abstract that away from you as much as possible. So you don't think about the server at all.
Okay.
And then the other part is you focus on just writing the code that is triggered whenever an event happens. So you write this code that only has a business logic because the platform itself is actually listening for events and actually responding to events and then triggering your code. So if you kind of think about a typical, like a Django or Flask kind of application, you sort of have to kind of set up that application, a lot of boilerplate, and then you get to write that code that you've kind of, that you want to write for your business logic.
Right. The interesting stuff.
Yeah, the interesting stuff, that you kind of trigger off of HTTP. But for us, for a lot of serverless platforms, you're going to respond to other events as well, like things appearing in a queue or, some object appearing in object storage.
Okay. So somebody could be dropping files somewhere.
Yeah. Things appearing in databases. Those can all kind of trigger a function to run.
Okay.
So those are a couple of things. And another thing is because you don't think about the servers at all, there is sort of like, it kind of feels like you have like infinite scale.
All right.
Whenever you have one event running, or maybe you have like all of a sudden you have like 100 events or 1,000 events or more coming in at the same time, we make sure that there's enough infrastructure there to spin out as many copies of your functions as you need to respond to these events. And then when nothing's happening, we actually scale you all the way down. And then that leads me to the last part of serverless, which is you typically pay for only what you use.
Okay.
So that would, in a function, that would just be your function execution. So that would be how much memory and CPU your function use while it's running and how long it ran for.
Okay.
And it's literally like fractions and fractions of a penny for every execution. And I think we give you 1 million executions for free every month. And a lot of the other platforms do that as well. So you can get a lot of stuff done for basically free on these server platforms.
Cool. So again, kind of going back a little bit to think about, the differences in their common setup that someone might think about for cloud computing several years ago, or even, depending on what you're trying to do, would be the idea of a virtual machine and picking out a particular amount of RAM that the thing needs, an operating system that it needs, and then maybe even having it has to have some sort of storage on board it for the virtual machine. And then like the next level of that would be moving into something like Docker or something, right?
Yep.
And then in that case, I had Tanya Allard on, and we were talking a little bit about the advantages there and sort of the portability of code, developing locally and being able to then take this code and put it up in the cloud and have it work there, or move it around in different places, and you're not having to worry about all the management of the machine. Well, this is even going up another level of abstraction, sort of, right?
Yep, exactly. Yeah. So you're not even kind of worrying about what your application itself is made of, like whether, like what web framework you're using. You're just writing that piece of code, and then you're just relying on the cloud provider to run that piece of code when you told it that it needs to be run.
Okay, so it's going to figure out what it's going to need to respond to the code that you've written.
Yeah, absolutely. So like I already mentioned a few of the events that can trigger functions. So you can even have a timer running. So you can say, hey, trigger my function every 5 minutes. And like the platform is going to just wake your function up,
right,
and kind of call it every 5 minutes. And your code gets to run. So your code can be just a couple lines of code doing something simple, because it's just code, you can bring in any packages that you want and actually do some pretty complex stuff with it if you wanted to.
Nice. And I was noticing, I spoke to Tanya actually last week a little bit before having this conversation with you, and she had done a talk on PyCon 2020, a sponsored Microsoft talk, talking a little bit about doing Azure functions there, and gave a demonstration. And in her case, I think it was an example where it was a timer, and it was triggering a particular event to go out to the web, grab this information, pull all the data in, do the data processing, all that sort of stuff. But what I was impressed with is that setting it all up, she was doing most of it just inside of VS Code and using not only the Python plugin for VS Code, but also there's an Azure functions thing that you can add to it. Is that right?
Yep. So our primary development platform, or like the development tool that we kind of support, is VS Code. So we have an extension there that allows you to just start up an Azure Functions application on your local computer. One thing we haven't talked about yet is that Azure Functions itself is all open source. So what that allows us to do is basically ship you that same runtime that we run in the cloud to your machine, so that you're actually running the same runtime locally in your machine, and you're able to attach a debugger to your code and actually step through your app as if it was running in the cloud.
Okay.
Yeah. And if you wanted to, you can also deploy it to the cloud from there as well.
Testing it and going through everything. So what I was wondering about is, so in that particular case, with this idea of it being triggered, basically there's nothing really running at all, except for just things sort of asynchronously waiting for events to happen, right?
Yeah. So we have some stuff running in the platform that's actually listening for these events, so that if your application hasn't been running for a while, we actually turn it all off. But then we still have things in our platform, something we call the scale controller, that actually listens to all these events on behalf of your application.
Okay.
So that when, like a month later, for instance, like this folder that you're observing in blob storage finally gets a file appearing in there. We will notice that, and then wake up your app and then call it. And then your application will go and pick up the file, do what it needs to do with it. And then if nothing happens for another month, we'll just kind of shut you down for another month until something happens again.
Okay. You used a term there that I see kind of thrown around a lot, and it's just kind of a funny term. And I just kind of wanted, maybe you could dive a little deeper into it. Blob storage, what is that?
Yeah, so it's this object storage. So it's typically people putting files into a very highly scalable kind of a container that's in the cloud. Typically, you can access it using HTTP, but there's other ways of accessing it as well. You can potentially mount it as a file share.
Okay,
but it's just a fancy term for a giant hard drive in the cloud that I don't have to deal with.
Okay, so you can use it. The one that I'm familiar with is S3. Is it similar to that in some ways?
Yep. So blob storage is basically Azure's version of S3. Yes.
Okay. And so you can, like you said, you can have it so that, like, I think of like Django apps or Flask apps that potentially could store rarely used files, or files that are a little bit larger than something you want to put inside of a database, and put them in that kind of storage. But on top of that, you could use this in a different way where it can be kind of a bit of a shared storage between, well, I think of virtual machines sharing the storage, but in this case, it could be these functions that are checking in that blob storage and using resources from it. Is that right? You could share it in that way?
Yeah, absolutely. So you already mentioned that like you can store kind of like application level data or user level data into blob storage. But internally within Azure Functions, we also use blob storage to store your code. So it kind of stores as a zip file that we mount directly into a function when it's executing.
Okay.
So that's kind of how we can kind of spin you out into like 100 instances and they're all executing the same code.
Okay.
Yeah. And then another thing that, especially for Python, that's useful is that you can actually mount like an arbitrary folder from blob storage into your function app. So what we've seen people do, something that we recommend people do in Python functions, because we're doing a lot of machine learning, is that typically if you need to kind of do any inference with the machine learning model, you would ship that model along with the application. So that makes your application code, your artifact, kind of huge. And then every time you iterate on a new version of that machine learning model, you have to deploy your whole application again. So that's not necessarily a great thing to do. Like it's totally doable. And I've seen a lot of people be successful with that, with a really kind of good CI/CD pipeline. But if you're just like, for instance, you have different teams writing the actual code that runs, like kind of like the server, the sort of the serverless function itself, like actually like writing the application code, but maybe you have another team of data scientists that are actually iterating on these models. You might actually want these things to deploy differently or separately.
Okay.
And that's where like being able to mount a folder from blob storage into your function app is really useful, because whenever the machine learning model needs to be updated, you can just update it in that folder. Potentially just upload a new one, so you don't even erase the existing one. And then you just tell your function, hey, now use this one. You don't have to redeploy your function. Maybe just reconfigure it a little bit, just pass it a new value. And then it starts using the new model. So that's really useful that way. So you don't have to redeploy your app.
Okay. It kind of brings up two thoughts I have, two kind of questions I have. Has Azure Functions always been friendly with Python, or is that something that's kind of new?
It's fairly new, new as in the last year or so. It became generally available within the last 6 or 9 months. So yeah, it is fairly new to Azure Functions. So the other languages that we support are, of course, with Microsoft, so we support C#, JavaScript, Java, even PowerShell for a lot of automation scenarios. We also have a feature called custom handlers that allows you to bring your own language runtime to functions as well. So Python's one of the ones that we added fairly recently. And because of the way that we kind of designed the functions platform, I kind of talked about the triggers, but we also have these things called bindings that I can talk about a little bit later. But all these things just light up in your function app.
Okay.
And don't really necessarily have to be rewritten by us to kind of support all these different languages. They just happen to work. So all the triggers still will work for Python the same way that they do for JavaScript, for example. Yeah. And then these things called bindings, they're a little bit unique to us, or to Azure Functions. So you can have a concept of input and output bindings. So we kind of already talked about triggers. So like say an HTTP request comes in, so your function will be handed the HTTP request, or maybe something like a message appearing on a queue. You will be given the contents of that message. That's pretty standard. That's pretty typical. But what we also allow you to do is you can set up these things called bindings. So you, for instance, an input binding, something that's pretty common is maybe you're kind of writing a serverless API,
right?
A web API, so that when you get a web request, you want to look up a customer. Without bindings, what you would do is you would get the request that says, I want, Christopher's information. And then you would have to create you'll have to kind of load up the SDK in your code for your database or your data store, and then use that to interact with that data store to pull back that data, maybe manipulate it, and then return it. What a binding allows you to do is that you can actually create an input binding in this scenario.
Okay.
So one of our databases that we have is called Cosmos DB. It's a NoSQL database. We ship both triggers and bindings for it. So what you can do is you can say, hey, when I get a message, like basically when my function triggers, also go off to Cosmos DB and pull in Christopher's information. And you can actually dynamically say, use this particular ID to make that call to the database. So you can actually pluck that ID out of your HTTP route, or maybe your query string or something like that, and tell the platform to go get that piece of information. And you can actually set up multiple input bindings for the same call. So the very first line of code that you write within the function, you already have both the thing that triggered it, as well as all these other pieces of information that you need to actually apply your business logic to it. And then we also have a concept of output bindings. So that kind of works similarly, but you're able to kind of output stuff to, for instance, if you want your function to actually send a message onto a queue, or maybe save a document into Cosmos DB, or maybe send a message over WebSockets, you can just bring in these output bindings and configure them with the right connection strings and stuff like that. And then you just literally just kind of return objects from your function. And then the bindings infrastructure will just know what to do with it. So you just return maybe a string or maybe even a JSON to a queue output binding. And that magically just shows up as a message on the queue. So again, that saves you from bringing in an SDK to actually deal with all this stuff.
And write all that code that does the connective stuff.
Yeah, exactly.
Okay, cool. Along with Cosmos, are you able to use other types of DBs inside the service also?
Yep. So you can actually bring in, like I said, you can bring in any SDK that you want. Cosmos is the main one that we support with bindings.
Okay.
Although currently I'm actually on a work stream trying to enable things like SQL Server as well.
Okay.
So look for those. Hopefully look for that to light up in the next few months.
Cool. So the other question I had, beyond doing stuff with Python inside of it, what are some common projects that you see people doing in it? You mentioned a little bit about machine learning inside there. Do you have some other examples?
Yeah, I think the main one that a lot of people use functions for is for HTTP APIs. So for instance, if you just want an endpoint for your mobile app to hit, or like that you just don't want to worry about, functions is a great way to put that API. One of the other advantages of functions is that it's HTTP by default. So if you want an HTTP endpoint for your function, it's there.
Okay.
You don't have to kind of do any extra setup to enable HTTP for your function.
Okay, so you would have an address or an endpoint sort of as part of the function.
Yeah. So we make that fairly easy for you to do. So we do find that a lot of customers are building serverless APIs with it. And then the other things are like service integration. So how you kind of glue something happening in Cosmos DB, but you kind of want to have some side effects. Maybe like, when a order gets created, it ends up in Cosmos DB. But then we also want to, send an email off or something. So you would actually have a function that has a Cosmos DB trigger on that particular orders kind of collection. And then whenever something shows up on there or something gets modified in there, your function gets triggered.
Right.
And then you can use an output binding. We have an output binding for SendGrid that you can use to just send an email from your function. And again, you don't have to worry about, how to talk to an SMTP server or anything like that. You just literally just return an object with a to and a from and your body. And then the binding takes care of talking to SendGrid to send your email.
Oh, nice.
Yeah.
Yeah. So SendGrid's like a service for, basically handling the email stuff for you. Is it just literally like something you just like use a checkmark box to say, I want to use SendGrid, or how do you add that onto your project?
Yep. So depending on the tooling that you're using, so for something like Visual Studio Code, you can actually just right click on a function and say add binding. And then we kind of walk you through this little wizard-like experience to be like, hey, what do you want to put it from the to address, from address, stuff like that.
Okay.
But at the end of the day, it ends up as a piece of JSON, like a JSON file that lives alongside your function.
Okay.
And then within that JSON file, it describes what the trigger is for your function, as well as any input and output bindings. So it just kind of flows in as like a, like a chunk of JSON with some properties in it.
Cool. I was thinking about it is, the whole concept of serverless isn't necessarily new. What are other examples of serverless architectures that are out there?
So in the Python space, we're seeing a lot of people running their machine learning inference on serverless functions. It's really useful for it because you quite often you would run these things in batches, so you would need a lot of compute.
Yeah.
At the same time almost. So having that elastic scale that the serverless functions provides, that's really useful for that use case. And same thing about like just not having to worry about if you get a surge of requests coming in for this kind of compute. I guess, like in any other kind of architecture, you would typically need to worry about, well, do I pre-scale out so that so I can have excess capacity when some of these things happen? Like, how do I deploy my applications to all these machines and things like that. With things like serverless functions, you just deploy a function once, and then you tell it to read from this model. You tell it to take this data and just use TensorFlow, whatever it is, to do your inference and return the value. So it's like you're able to kind of stay in your application code without worrying too much about infrastructure.
Yeah, I was thinking about, I have a fairly old desktop computer, and in the Apple world, it's definitely nice for certain things like doing development in it. And I do all this video and audio stuff, obviously, for real Python. But one of the downfalls is it seems like for doing something like machine learning and doing some of this more mathematical processing that, you almost want these outboard GPUs. And so I think of maybe serverless being an answer for something like that, where like, my machine isn't going to be able to do this code very quickly or easily. And so maybe I could farm that work out. Is that a common solution also?
Yeah. So one thing that we don't quite yet support are GPUs, but what we also see people do with serverless functions is that you still use that as your kind of port of entry, or the thing that triggers something that runs.
Oh, okay.
But you might actually take these things and actually call out to something else.
Yeah.
For us, we have a few kind of different computing platforms. We have a serverless container kind of platform that you can just spin up a container with a GPU. So you can actually use a function to spin up one of those things to actually do the actual compute. And then another thing that you can do is, like, if you have like a batch platform,
okay,
same thing. You can use function as a way to trigger one of these jobs, but you're actually using another platform to do this work. Quite often, this works a lot better because you tend to find that people want like really specialized compute, and because for functions, you typically don't want to think about what kind of compute you're running on. So it's a little bit, it's a little bit of a disconnect to be like, well, I don't want to manage my servers, but then also I want this very specific GPU on it. So we do see a lot of people using functions to coordinate other work that's outside of the functions platform.
Okay. So where would it call out to? Like, where is it finding this compute resource? Terminology that I'm not very strong with. Sorry.
So one of these things is, like, for us, we have a platform called Azure Container Instances. So you are able to kind of basically spin up a Docker container, but you just don't really think about what it's running on. So you can say that I just want a Linux machine with this much RAM and this much CPU.
Okay.
And optionally, you can say I want it to run with GPU. And it'll just figure out how to run it. So the analogy that I always kind of try to think about when I think about container instances is virtual machines know how to run virtual machine images.
Okay.
And container instances know how to run Docker images. So you don't really kind of have to think about it too much. You've already kind of built your Docker image. That's the harder part. So so in one of these scenarios, you might have like a pretty kind of compute intensive kind of like an application in there that can potentially maybe take in some file and run it through a machine learning model on a GPU. Or maybe you're actually doing the training phase of your data science workflow in there. And what you can do with functions is that using like an SDK, and every function, you can actually assign an identity to it. And in Azure, you assign an Active Directory identity to it.
Sure.
And you use that identity to actually talk to Azure with your SDK without really writing any extra lines of code to spin up one of these Azure container instances, for example, so that when a job...
So it's acting like a user, sort of?
Yeah. So it's a thing that we call a service principal, which is a fancy way of saying it's an account without a user.
Okay.
So you're able to kind of lock that down to, very specific resource groups or subscriptions.
Okay.
So they can only do the things that you told it that it can do.
All right.
Or you told Azure that it can do.
Right. Okay. These are the only places you can go, and these are the only things that you're allowed to do.
Yeah, exactly. So you're able to use that in your function code to spin up these containers if you wanted to, that actually does the more heavyweight compute.
This week, I want to shine a spotlight on another Real Python video course. It's called The Beginner's Guide to Pip. It's by Real Python instructor Austin Sapalia. Pip is a standard package manager for Python, and it allows you to install and manage additional packages that are not part of the Python standard library. In the video course, you'll learn about installing additional packages that are not included with the standard Python distribution, finding packages that are published to the Python package index, PyPI, managing requirements for your scripts and applications, and uninstalling packages and their dependencies. I think it's a worthy investment of your time. This course is a great introduction to pip for those who are getting started with Python, and for those who want to understand more about what is happening when you use it to install new packages into your environment. And like most of the video courses at Real Python, the course is broken into easily consumable sections, and you get code examples for the techniques shown. Check out the video course. You can find a link in the show notes, or you can find it using the newly enhanced search tool on realpython.com. I guess kind of going back a little bit to talk about, setting this all up, would you say that VS Code is the preferred platform for that? I mean, I know it's open source in the sense that, it's basically freely distributed and you get it on Windows and Mac and Linux. I even installed it on a Raspberry Pi. So is that the preferred platform for working with Azure functions?
Yeah, VS Code is definitely the thing that works the best for pretty much all the languages. For Python, we do have folks that want to use things like PyCharm and stuff like that. So for those, currently, we don't have integration with PyCharm yet.
Okay.
But what we do have is we have a pretty decent CLI that you can download called the Azure Functions Core Tools.
Okay.
And that just has a bunch of commands in there that allows you to initialize a project. So a project is basically a folder. So you can call func init, and then that kind of creates all the files that you need to get started with the application. And then you can...
that you would have like the triggers and stuff, right?
Yeah. So that CLI allows you to kind of, so you can create these files. So the next thing that you can do is you can say, hey, create a function. So you can, and then it's going to walk you through a little kind of command line wizard. So you can say, hey, I want a function that triggers off of a queue, give it a name, and then it kind of stamps out that function. That's basically a folder and a couple of files.
Yeah. And
then you can start partying on that. So it's going to basically set up the initial configuration. In this case, would be the queue trigger, that piece of JSON that you need to get functions to know that you have that queue trigger and any kind of other bindings that you have.
Cool.
Yeah, and then what the CLI also allows you to do is that we ship within the CLI that function's runtime, that same function runtime that we run in the cloud.
Okay.
So once you have your application kind of built, you would just call func start, and then that will start up that runtime and load up all your functions. And then those functions can talk to things in the cloud. So for instance, if you have a Cosmos DB trigger, for example, you can actually have that connect to Cosmos DB in the cloud. So you can actually go to your Cosmos DB, modify or create a document, and that actually triggers your function locally on your machine. And then you can actually attach a debugger to your function, and it'll actually pause there. And you can debug it just like any other Python application in VS Code.
Cool. Yeah, you were kind of talking about basically you could set it up as long as you're comfortable using the CLI commands and do all that sort of local development, just like you were doing, like we talked way at the beginning there about setting it up inside of VS Code then.
Yeah. So the goal is that you can actually have your function running locally pretty much the same way as it does in the cloud before you even deploy it. So for Python functions in particular, we make heavy use of virtual environments.
Yeah.
So we try to make sure that every function app has its own kind of virtual environment and its own kind of requirements.txt file.
Okay.
So that when it becomes time to deploy it to the cloud, whether you're building it locally and then packaging up this bigger zip file and then deploying it to the cloud, we also support remote build as well. So you can actually just package up your Python code and your requirements file.
Right.
And then off in the cloud somewhere, we're running that build for you. So you're deploying a smaller artifact. The deployment does take a little bit longer because you're actually not doing the build on the server. But at least you don't have to kind of worry about running that build, especially if your application actually depends on something that has some native dependency. So for instance, if you're running on Windows or Mac,
okay,
but you actually need to kind of pull in a library that actually has a native dependency on something that's built for Linux. So if you actually package up the app that you built on your Mac machine, for example, and then ship it off to Azure, it might not work because that particular package that you brought in has a dependency that is platform specific. So what we kind of allow you to do is run this build in the cloud. So that build runs in the same environment. In our case, it's Linux, as it's running on when the function is actually triggering in the cloud.
Okay.
So it's able to pull in the right dependencies and build that package that's guaranteed to run well on our platform.
Yeah, and I was thinking that one of the things while I was watching Tanya's demonstration, the YouTube video, she was also in setting up that virtual environment. She was picking the version of Python that she wanted to use in there. Obviously with now a yearly update schedule and some interesting stuff coming down the pike with new versions of Python, it's something you would want to be able to at least plan for and test for. So that's kind of nice. But so the whole thing is basically the serverless base is on Linux.
Yeah. At least for Python, we know that Python runs really well on Linux. So we just make sure that that is the place where we deploy Python apps. For some of the other applications like .NET apps and JavaScript apps, we actually give you the opportunity to choose whether you want it to run on Windows or Linux. For the most part, it doesn't make that big of a difference. You might actually have something that depends on a specific platform where it might matter, but for the most part, they just deploy and kind of run the same way. Yeah, and then if for some reason that you just need a very special environment, so sometimes we kind of, in Python, some people might want, like, what if I want Conda and like some kind of specialized Python environment? We actually allow you to bake your own Docker container. So the Docker container itself will have the environment, like basically all the stuff that you need that we don't have in our platform natively. And then it also contains the functions runtime, as well as the bits that allow you to run Python functions. And then, of course, you have your Python code in there as well.
Cool.
Using the same functions core tools tooling, we help you build that Docker container, and then you can push that off. Actually, I think we even help you push that off to a registry somewhere. And then now you can, so instead of deploying code to our platform, you can say, hey, please run this Docker container.
Sure.
And then so you have a very specialized container that has all the stuff that you need. So sometimes you might have like a native, like an OS level dependency that we don't have necessarily on our kind of default image that we kind of run your code in.
Okay.
That's where you can kind of almost break the glass and just build your own Docker image and deploy it. So we have like different plans to deploy your function apps to. So the serverless one, the one that we typically talk about is the consumption plan. That's the one that you kind of pay by the request. But we also have another plan called the premium plan.
Okay.
We still scale you in and out the same way based on events as we do in the consumption plan. But what the premium plan allows you to do is you can actually run things like a Docker container. You're still kind of built for what you use, but you're not built for the request anymore. You're actually built for the compute. So for instance, if your app needs to scale out to, and this is where like some of the serverlessness kind of leaks, like the servers actually leak through a little bit. In that, if you
start seeing them a little more.
Yeah, you kind of start seeing them a little more because so when you start running containers and stuff like that, you do kind of tend to like see that a little bit more. So you kind of build for the number of seconds your code is running.
Yeah.
But aside from that, it more or less scales the same way. You have more compute choices. You can actually have like beefier machines if you wanted to than the single core machines that we run your code on.
Okay.
So sometimes you might need to kind of choose that, or if you have some kind of special networking options that you need. Currently, we have some more advanced networking version options, our premium plan. So you can kind of pick and choose. I mean, one thing that we haven't even talked about yet is that with Azure Functions, you can actually run it almost completely outside of Azure in a Kubernetes cluster. So because your functions runtime is now baked into a container, you don't have to run that container on our cloud. You can go off into your company's Kubernetes cluster.
Like an intranet kind of thing.
Yeah, and just deploy it to your Kubernetes cluster inside your firewall. You can still take advantage of that same programming model, so not having to worry about building the app itself and only focusing on what's on the function.
Okay.
At the end of the day, you're just deploying it instead of to our compute, you're deploying it to Kubernetes in this case. And that scale controller that I talked about earlier, the thing that knows how to listen to events and scale your app in and out, we actually ship an open source version of it.
Okay. So that's going to help with the infrastructure there too.
Yeah.
Okay.
Yeah. So you can actually use that to scale your function app to basically 0 on your Kubernetes cluster.
Yeah.
Without doing really a lot of work. You just have to deploy this extra component to your cluster. And then you kind of have the same kind of scaling that we offer in the cloud. So all of a sudden, this thing that you're listening to, whether it's like a RabbitMQ queue or like a Kafka cluster that you're kind of listening to, like if all of a sudden you get a bunch of messages show up in there, this component called Kata, Kubernetes Event-Driven Autoscaler, will automatically scale out the number of pods that are running your application so that you can consume those messages or whatever it is as quickly as possible. And then when it's done, you'll notice that your queue is empty, and then it'll actually scale your application down, eventually down to 0. But then it's still, centrally monitoring all the different function apps, event sources for you, even though there's no instances of those apps running anymore.
Huh.
Until they need to spin up new instances again.
I mean, it sounds like Kubernetes is like a whole rabbit hole that I haven't even dived into in the podcast yet. What I'm thinking about is that what you're saying with the system is in some ways you're not having to do quite as much. I don't know, I forget the term for the role that is involved, sort of infrastructure engineer. It sounds like it can kind of automate a lot more of that infrastructure engineering for you.
Yeah, for sure. So like typically, if you have like a Kubernetes cluster, you normally have a like a specialized team that kind of that's in charge of operating that cluster.
Yeah.
As a developer, you typically don't want to worry too much about that cluster, how it works, patching it, and all that stuff. You just want to deploy your code. Right. So in this case, you have to do a little bit more in that you have to build that Docker container with your application in it.
Hopefully.
But then from there, you should just be pretty easily deployed to your Kubernetes cluster, either through your CI/CD tool or some other means. And then it should just run. And because we have, you can install that scale controller, that Kata component in your cluster to do that scaling.
Okay.
It'll just notice that your app got deployed, and it understands the different data sources that you need to listen to. And then it just starts listening to those data sources, those event sources, and starts scaling your application in and out.
Yeah, cool. So we dove a little deep into advantages. We talked about the idea that it's kind of nice in the sense that it's not your computer with serverless. The ability to grow and handle lots of events, and when nothing's going on, to basically scale back down to nothing. The idea of it being set up to be triggered, the idea of having an IP ready to go for it, and kind of a nice, easy way to create an API without necessarily having to, get into hosting and all the stuff that's kind of maybe involved in that. Am I missing other advantages? I think we hit quite a few of them.
Yeah, I think we hit most of the key ones there. Yeah, like you covered them pretty good there in that recap.
Okay, so what are disadvantages? Why wouldn't you want to go this route?
You actually kind of covered it there as well. It's not your computer. Yeah, it's not your computer.
It's not my computer. Okay.
So you don't get the knobs that sometimes you need to kind of tweak, right? Like you don't, for instance, have control over that IP address that you really want to control. Or some of that you can kind of solve by shipping a container instead.
Okay, getting that more advanced plan kind of going.
That's not always possible. So you have less control. And then the other thing is, because we are charging you by the request, we have to be super smart about how we scale your application in and out. So sometimes we scale your application down to 0 when nothing's happening. And it might actually take a little bit of time for it to notice something that is happening.
Right.
So for HTTP, it might be a couple of seconds, maybe even a little bit longer, to perform what we call a cold start.
Right. I was thinking that.
But a cold start really only happens, or is only usually noticeable when you're scaling from 0 to 1.
Right.
What our kind of load balancer does is that it kind of just holds on to that request while your application spins up, hopefully within a couple of seconds, and it starts routing requests to it. And then there's a slight difference between how Azure Functions implements our runtime, I guess, versus some other platforms. So for us, we can actually handle many concurrent requests inside of a single instance. So even though the cold start might be a couple of seconds, once that spins up, that single instance can actually handle multiple requests. So for instance, if you have all of a sudden, 10 or 20 requests hitting this thing at one time, you kind of just pay for that cold start once, assuming your app was actually sleeping. And then after that, it just responds really, really quickly.
And you mentioned it there, other services. So the one I was familiar with before Azure Functions would be Amazon's Lambda. Is that correct?
Yep.
Okay. Are there other companies that have these kind of serverless tools out there?
So I guess the other main one is Google with Google Cloud Functions, as well as Cloud Run, which is a pretty interesting spin on serverless. So you can actually run any container that speaks HTTP. So kind of any HTTP server, and they'll kind of run it for you. And you pay for the requests that your HTTP server receive.
Okay.
Our runtime model actually is almost like a hybrid of the two between something like Lambda and Cloud Run. So we actually spin up an instance that is able to handle multiple requests at the same time. But our difference is that we have, instead of making you ship a Flask app in a container, we actually provide that runtime for you. So you're just writing that function.
Cool. And then there's something that is kind of coming out pretty recently. I think you guys are maybe even talking about it at Build, some upgrades to the Azure functions themselves, right?
Yeah, so the main one is that we're announcing Python support for this feature that we have called durable functions. So durable functions, in a nutshell, is a way for you to kind of describe or write these longer running kind of workflows or orchestrations in a serverless manner using application code.
Okay.
So I guess one thing that we can do is we can kind of talk about some of the disadvantages of serverless functions typically. So for instance, if you wanted to run like a ETL job, for example, or some other kind of long running job.
Okay. So you're doing I forget the term, it's extract, transform,
Yeah.
and load. Okay. So it's like basically data processing to get stuff into a database the way you want it.
Yeah.
Right.
Yeah. Sometimes those run on a schedule overnight. It could take a few hours. Like they could fail halfway through and things like that. So for all the serverless functions platforms, there is a time limit on how long functions can run.
Okay.
So in our case, it's in Azure Functions, it's 5 minutes. You can extend it to 10 minutes if you wanted to. Other platforms are about the same. Maybe they can go up to 15. I mean, some of our other plans will actually allow you to run almost for as long as you need to. Like, for instance, in Premium, you can have it run for an hour or maybe even longer. But the problem with that is, like, these longer running jobs typically do a lot of stuff in it. You don't want a job to kind of run, like a 1 hour job to run for 58 minutes and then it fails there. Then you have to restart the whole thing again, right? So,
ouch.
Yeah. So one of the things that you might want to do is you can actually decompose your workflow or your kind of ETL process into a bunch of smaller functions that can run within the limits of a serverless function. So that you can say, hey, go and, for instance, maybe like go build up this database, now load it with data, now run some analysis on it, and now tear it down.
Yeah, sure.
So potentially these things can take, a long time, right? So you don't want all that stuff to happen within a function. And even if you could run a function for an hour, for example, you might not necessarily want to do that because, for instance, maybe you have your database created,
okay,
and then something happens in the data loading, and then like, what do? Like you have to go back and maybe clean up the database. You can't just, go run the function again.
Right. Or rebuild it from scratch again.
You can definitely have some logic in your function to kind of compensate for a lot of these things, but it's not super easy to do. So one of the things that we allow you to do in durable functions is that you can actually write this piece of code. It's still a function, but it's a function that orchestrates other functions. So within this, like, so you can, I try not to kind of talk about code when I can't share my screen, but it's actually fairly simple. It's just a Python function, and then you just have ways of calling out to other functions. But what the platform does and what the durable functions infrastructure does for you is that when you make these calls, we actually checkpoint for you.
Sure.
And we actually put your orchestrator function to sleep. So you're actually not paying for the orchestrator function while you run, like the activity function that actually loads your database, for example. That thing is going to go off and do its thing for you.
All right.
And then when it's done, it's going to wake up the orchestrator function again. And then it's going to basically carry on and do the next steps. So what's good is that the platform itself takes care of a lot of the checkpointing and stuff for you. So for instance, if one of your steps fail, you can actually have, once again, some normal Python code, some try except statements, maybe a while loop to do some retries. We even have ways of actually doing retries for you automatically.
Okay.
So you can just write typical Python code, but what happens behind the scenes is we're just using some queues and some storage to basically, create and run these other functions, maybe on the same machine, maybe on another machine. What's serverless? You shouldn't care about the machine. We'll make sure that runs, and then we make sure that they run to completion, and that you have ways of dealing with errors. So you're able to kind of describe this workflow,
okay,
without resorting to things like, for instance, you can chain a bunch of these functions together with queue messages. But what do you do if you want to write an error handler on top of all of these functions, right? Kind of difficult to do when they're all kind of separate like that. So we kind of do all that work for you.
Okay. You're almost templating the process of creating this conductor orchestrator to help you plan out how you're going to have all these separate functions be started and controlled. And I don't know, am I speaking too broadly? But it sounds like you're doing some of the work as far as like preparing Python master function, if you will, that's going to be orchestrating everything.
Yeah, absolutely. Yeah, that sounds exactly right.
Okay.
Yeah, so you're able to do things like function chaining. Another thing that that we see people want to do, and we see people do already in the C# and JavaScript flavors of durable functions,
Okay.
is doing like a fan out and fan in kind of an activity.
All right. What's that look like?
Yeah, so another thing that's kind of difficult to do in serverless functions, if you're just working in the confines of a single function, is like currently, I think like on our platform, we give you a single CPU. I believe other platforms give you a single CPU as well. But what if you want to just do a bunch of work all at the same time,
Okay.
right? You actually want to be able to fan out to, many, many different machines and have that work done really, really quickly and then be able to fan back in. Without durable functions, you can still do that. You can create basically a queue and just chuck a bunch of messages on it. And then that will trigger a bunch of functions that respond to those messages. And then they will run on different machines and complete those jobs relatively fast. But typically the hard part is actually how do you fan all this stuff back in? How do you know when all of these things are done and that you can carry on? Maybe you can actually aggregate and do summarization of all the results. That's actually really hard to do. And durable functions does that pretty much all for you. Behind the scenes, it's still using queues to do all the coordination.
Cool.
But for you, you're just writing a piece of Python code that's probably a little bit more complicated than what I described for the function chaining case. In this case, you would just have some code,
Okay.
and then maybe you have like a list of IDs or like basically data to process that you kind of want to fan out. Maybe 100 of them, maybe 1,000 of them. You can sort of imagine kind of just in a loop, just calling this call activity function that basically just schedules a job to be run on another function. You call it 1,000 times with every one of those IDs. And then you can say, hey, wait for all these to finish. And this would just be a single line of code that says, hey, wait for all these to finish. And then you can actually get the result of all of these things, basically assign it to a variable.
Okay.
And then carry on to some kind of maybe like some kind of summarization task. Or maybe you fan out again to do something else, right? You can sort of describe that flow. You can just describe it with basically a for loop and sort of like a wait kind of a statement. But what happens behind the scenes, even though your Python code looks like, like 10 lines of code that just made some calls to some functions, behind the scenes, we actually schedule these other activity functions to run to kind of span out into as many machines as we can give you to run so that they can finish really quickly. And then when the result comes back, your orchestration function wakes up again.
Okay.
And you get the results, and then you can use that to do anything else you want in your workflow.
How long has that been around on other platforms?
So that's been around for about 2 or 3 years.
Okay.
So it started out with C# and JavaScript, and we are adding Python and PowerShell. So we're seeing a lot of people for Python, a lot of people who want to use it for machine learning scenarios, like basically fanning out to do a lot of just like machine learning kind of inference.
Yeah.
And also a little bit of automation as well. So if you kind of want to be able to orchestrate like other pieces of, like I was saying earlier, like you can actually tell other pieces of compute to do stuff in Azure. So so we actually have some customers who have like thousands of these machine learning jobs that they want to run. They don't necessarily want to run them on functions because, like, to be quite honest, like it might not be the best place to run it because of the CPUs that we have. But they use functions and durable functions to actually orchestrate the running of this other compute. So for instance, you can, the very first step would be, hey, just get all the data that I need to process. And then maybe the second step is I want to spin up all the compute that I need for my job.
Okay.
And then you can kind of do this while loop thing and actually send the jobs to the different pieces of compute that you've spun up.
Right.
And then you can actually use basically another loop,
Okay.
maybe a loop with a timer in it, to actually monitor these jobs. And the way that these timers work, it works kind of the same way as if you were just calling out to a function. When you call one of these timers and say, hey, like, wait 5 minutes before you check again, or maybe even wait a day, wait a few days before you check something again. It actually puts your orchestration function to sleep. So your orchestration function doesn't cost any money at all. Like every time the orchestration function runs, it literally runs for like a few milliseconds. So it's basically free to run. And all these other activity functions are built the same way as we bill you for regular Azure functions.
Yeah. That makes sense.
So you're able to kind of do this kind of like provisioning some machines and almost like a function chaining kind of a thing. And then you got fanning out all these jobs to all these machines to actually do.
Yeah, it's just like this really powerful controller you're building.
Yeah, and then you would have another loop, or you can even have a loop for every piece of compute that you spun up that's able to monitor what's happening in there. Again, you can describe it in an orchestration. You can actually, like if your orchestration gets complicated, you can actually split them into sub-orchestrations.
Okay.
So an orchestrator can actually call different orchestrators that actually end up calling activity functions. We actually have some customers that are
Right.
that have these things nested pretty deep.
Wow.
And they're like running at like very, very high scale. So it's very kind of interesting to see what you can do with it. But at the same time, you can reason about it, the code fairly easily, because typically, if done right, these orchestrator functions are like 10, 20, maybe 30 lines of Python code. So you can actually just read through what your workflow looks like. You can see at a glance what the error handling and retry logic looks like, because they're just try except statements. They're just while loops. So typically, you are able to express your workflow a lot more easily than, say, for instance, like maybe you can describe a workflow in a piece of JSON, but that becomes a little bit difficult to do when your workflow gets more than a few steps with some error handling and stuff like that.
Yeah, you really get into actual logic.
Yeah.
Going inside of it. Cool. So when's that coming online?
So we're hoping that by the time that this podcast airs, that we will have the public preview of it.
Cool.
Even if we don't, I'll share a link to this kind of pre-public preview tutorial thing that you can try.
All right. Sounds good. Awesome. So I have a couple questions that I hit on weekly here on the podcast. And so the first one is, what's something that you're excited about in the world of Python? It could be a package, it could be hardware or an event.
Yeah, so this is something that I've actually started literally looking into today. So one thing I didn't mention is that I'm a bit of a polyglot, and
Okay.
I am fairly new to Python, like within the last year, maybe using it casually for like a year and a half. It wasn't until I kind of like took over some of this Python and durable functions for Python stuff,
Okay,
that I started kind of diving into it. But on other platforms and other kind of frameworks and stuff, I've always been like super fascinated by these real-time frameworks, things like Socket.io on Node. On .NET, there's this thing called SignalR. I've actually, like, we actually have a service in Azure that all it does is WebSockets as a service.
Okay.
Called the SignalR service that I've been really involved with. We even have a binding in functions to send messages to connected clients over WebSockets, thousands and thousands of them, by just returning a piece of JSON to a binding. So I've always been like super fascinated by real time on pretty much any kind of web framework that I kind of work with. So I've been trying to dive into like, what is the Socket.io equivalent on Python and in Flask? And I kind of discovered that they actually have Flask Socket.io. So I'm going to start diving into that and seeing what kind of silly stuff I can do with real time on Flask.
Cool. And I don't know, this might actually be pretty related to that. The other question is, what do you want to learn next in Python?
So another thing that I've been kind of diving into, especially as I kind of start learning about how like a lot of these workloads run on Azure Functions, especially like CPU intensive kind of workloads, is how like threading works in Python. So things like async IO, there are sort of like parallels, or at least I can reason about them.
Sure.
Kind of the same way as I do with the event loop in JavaScript, for example. Threading is something that kind of caught me by surprise, in that I just thought that if I just put stuff onto threads in Python, that they would just run on multiple CPUs. Turns out it's not necessarily that simple. And actually, like the first things that I actually did was kind of like, once I kind of realized that wasn't that simple,
yeah,
I Googled it and actually landed on a real Python article.
Yeah, cool.
So I'm just diving into the different behaviors and threads and what they're good for, and more importantly, what they're not good for in Python, and different ways of getting around that. So really kind of fascinated by a lot of this stuff.
Yeah, awesome. That's something I want to dive into a little more myself. Thinking about bringing somebody in from the team to talk about threading.
Oh, I would love to hear that.
Okay, cool. Well, I really want to thank you for coming on the podcast and taking time to talk to me and tell us all about serverless.
Yeah, thanks so much for having me.
All right. I want to thank Anthony Chu for coming on the show this week. And I want to thank you for listening to the Real Python Podcast. Make sure you subscribe to the podcast in your favorite player. And if you like the show, leave us a 5-star rating and a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and look forward to talking to you soon.